Hey guys, it's Mrs. Howell. Today we're going to look at lesson 10.5, which is titled Line Symmetry. And it starts in your Big Go math book on page 399 and runs through 402. Our learning target today is going to be to recognize lines of symmetry for a two-dimensional figure. And essentially, a line of symmetry is a line across the figure such that the figure can be folded along the line into matching parts. Sometimes you'll hear when you see matching parts, it means a mirror image or even a reflection. So that's what we're going to be focusing on today. Are looking at shapes for lines of symmetry, and if we fold them or we draw a line on them, would we have two matching pieces, identical pieces, so they're mirror images of each other or reflections of each other? I have three examples down here below because not all shapes have lines of symmetry. Some might have a few, some might have one, some might not have any. So I have these three figures down here below to model each type of that. So we have our smiley face. He's pretty perky. So I'm going to just kind of have this line of symmetry. If I were to put it like right down here, right down the middle, and fold it. Now I'm probably a little bit off there with my line, but if I were to fold it right identically down the middle, and kind of sandwich it together like a taco, the left hand side and then the right hand side would fit and fall exactly on top of each other. So they would fit and be a mirror image of each other. So our smiley face has one line of symmetry. Now, if I take that same smiley face and I draw a line, instead of having it be vertical, have it be horizontal, like this, you could see that if I were to fold it from top to bottom like a taco, that the eyes aren't gonna have eyes down below, and the mouth isn't gonna match a mouth up top. So in that instance, your eyes and your mouth, aren't a reflection of each other. They're just two different things. So with our smiley face, it really just has one vertical line of symmetry here, where the eyes, if I were to fold it, would match up, and then the mouth would also match up. Now, our next shape, we have our square, and our square actually it's a good example of a shape that has a few lines of symmetry. So if I were to draw a vertical line right down the middle, again, bear with me on my finding my middle with the pen online, so it could be a little bit off. So if I were to draw a line vertically, kind of like a Post-it, and I think I've shown that in class before, where if you have a square Post-it and you fold it in half like a taco, you would have two matching sides. Likewise, you could also draw a horizontal line of symmetry where your top and your bottom, if you were to fold them, would also match identically. And a square is nice in that as well. You could go diagonal. So you could go corner. Oops, it started off bad there. So you could go corner to corner, and when you split it corner to corner, going diagonally, you create two identical triangles. So if you can go from this top corner to this bottom right-hand corner, you could also go diagonally the other way. So you could go from this way and create two identical triangles. So with our square, you actually have 4 lines of symmetry, and I'll draw them one more time for you. So you have a vertical line, you have a horizontal line, and then you have, going corner to corner, 2 diagonal lines. where when you draw either one of those, it's going to create two identical mirror images or a reflection of itself. Lastly, we have our letter G, and our letter G is an example of a shape or an object that does not have any lines of symmetry. So, for example, if I were to draw a vertical line here, you can see that this left side here would never fold over and match this right side here, because you have like a little gap here. You have this little thing here that kind of like sticks out. So if you fold it vertically, there is no line of symmetry. And then let's try drawing a horizontal line. So if I were to go left to right now, you can kind of see again that yes, you do have a curve here and you do have a curve down here, but look at this gap right here. If I were to fold that over, there should be a gap here, and there isn't. So they are not identical to each other. So the letter G does not have any line of symmetry. So that's important to recognize that, some shapes can have several, like our square. Some may only have one. It could be vertical, it might be horizontal, diagonal, like our smiley face, or there are shapes that do not have any. Okay guys, on page 399, the Unlock the Problem, I really want to focus on our definition for line symmetry and move on to page 400. It says a shape has line symmetry. A shape has line symmetry if it can be folded about a line so that its two parts match exactly. A fold line or a line of symmetry divides a shape into two parts that are the same size and the same shape. So again, they are a reflection or mirror image of each other. Now, do understand that a line will not, and usually will not, be there for you. You will have to A, imagine it for yourself, or B, what I would recommend is to just kind of like lightly trace a line onto some of these shapes and figures we're going to be looking at. So, it is always good to kind of visualize the diagonal or the vertical or horizontal line. But, if you have paper pencil in front of you, just go ahead and just quickly, lightly trace a line to see if in fact it does create two identical images. So that would be my recommendation. We're going to use this, the picture of our Hollywood sign that's located in Hollywood, California. And we're going to look at some of the letters in that sign. So go ahead and flip to page 400. Okay, friends, on page 400 it says, does the letter L have line symmetry? It says use pattern blocks or grid paper, but we're really just going to use kind of the picture in front of us and use our pencil to draw lines on it to see if in fact we can prove it does have a line of symmetry. So let's look at step number 4. It says fold the tracing over a vertical line, and really I'm just going to kind of highlight this a little for you. So if I were to draw a line here vertically on the sort of on the right hand bottom section of our L, you can kind of see that this section is not a mirror image and does not fit exactly up against this sort of tall column of the L. So do the two parts match exactly? No, they do not. What if we draw a horizontal? Horizontal meaning go left to right. If I draw a horizontal line, if I were to fold this top portion over, yes, that would fit on top of this section. But you can see right here we have this little kind of like the little edge that juts out. And if I were to fold that up, if I were to taco those, there's nothing right here to match it. So when I draw a horizontal on the L, no, they do not exactly match up. The top and the bottom do, as far as on the left hand side, that big column, but it's the right hand side of the L that won't match up. And then lastly, step number 6, if I draw a diagonal here, if I were to draw a diagonal and fold it, I know I'm just looking at this section right here. This guy, when I fold it over, is not going to be a mirror image to that bottom part of the L. So no, a diagonal line would not work either. So the letter L does not have line symmetry, just like that letter G. Letter G and letter L, we've already proven to not have line symmetry. Let's go ahead and look at number 1 and number 2. And we're going to look at just a few other letters from our Hollywood sign. It says repeat steps 1 through 6 for the remaining letters in Hollywood, and which letters do have line symmetry. So I'm going to just look at our letter H right here. So I have my letter H. If I were to draw, let me pick a different color here than red. So if I were to just do this vertical or horizontal line right here, if I were to fold them down, like a taco or hot dog bun, they would actually match. The top section and the bottom would be a mirror image of each other. Likewise here with my letter H, if I were to do a vertical line right down the middle here, and taco them and fold them on top of each other, the letter H would have a vertical line of symmetry. So H actually has 2 lines of symmetry. If I were to go diagonal, it wouldn't. If I were to go this way or the other way, top to bottom the other way, those parts do not match. So H, yes, does. And then we have so I'm going to add H right here. So H would work. Let's see if we can find any others. How about our letter O? So if we have this, an O or 0 is actually going to have just kind of, and you should remember this from the video. If you go through the center, sorry, that last one was not a very good example right there. If you go through the center always, your O is going to have an infinite number of lines of symmetry. A bad example, though, would be if you have your O and go like that. Like that wouldn't work. It has to go directly through the center of the O. But O would have an infinite number of lines of symmetry. And then, well, that was terrible where I put that. Let's look at, we've already proven L not to. What about Y? I'm thinking yes on Y. Let's add O. So if I have, and my Y would have to be like that, not like a loopy cursive one. For my Y, if I do and again, just kind of off to the side, just, you have your vertical line here, and you can see that on the left side and the right side, they match exactly. You have those two sort of, it's almost like a little V pointing up. Those would match. So Y would have a line of symmetry. And then our W, ooh, that's a good one too. Let's just look at W. And then I have to, so my W is kind of like this though, right? So this W, if I were to do a vertical line of symmetry, you can see it kind of splits it and has 2 V's on either side. You have a V here, and then you have a V there. And then you fold those together, they would match identically. So W also has a line of symmetry. You could not go horizontal with that one though. And then lastly, our letter D. So let's add W here. And then let's look at our letter D. I think D will as well. So if I have my letter D, interesting on this one, I know I typically start vertically, but if I go vertical, you can see I have a curved side here and then a straight side there, so that would not match. However, if I go horizontal, you could see that I have a straight and then a curve, and then I have a straight and a curve. So going a horizontal line of symmetry would actually create a mirror image. So it's not always vertical and it's not always horizontal. It could be one or the other or none. And then diagonal too. Sometimes you have that diagonal. So let's add our letter D. So Hollywood actually has lots of letters with lines of symmetry. And then we prove that. Number 2, do any of our letters have more than one line of symmetry? There was 2 of them. So we had our first 2 actually. So you have H and O have more than one line of symmetry. All right, guys, let's flip over to page 401. Okay, guys, on our share and show, it says, tell whether the parts on each side of the line match. Are they a reflection of each other? And is the line a line of symmetry? Right, yes or no? So if it's not a match, then it's not a line of symmetry. So we would put no. Rectangle goofs people up sometimes. You know, I will say this is probably one of the trickier shapes. You do have with a rectangle, you would have a vertical line of symmetry, and you would also have a horizontal line of symmetry, but the rectangle is different than the square in that you cannot go diagonal. If I were to fold this line over, or that corner over, it's not gonna match up exactly. It would need to fold here, and it, you know, if I fold that over, it's not gonna meet this corner right here. So the rectangle actually does not have a diagonal line of symmetry. It just has vertical and horizontal. So in this case, the dotted blue line is not or would not be a line of symmetry. Number 2, I do see we have 2 identical sort of turned triangles there, so that would be a yes. We did our smiley face earlier, so that would be a yes. Our number 4, our triangle, if I were to fold this point over, right, if I were to fold it over, you know, and if I were to fold the bottom up to the top, you know, it's not gonna match exactly. I would definitely have some corners hanging over there. So number 4 would be a no. Number 5 would be yes. This guy right here does create 2 identical mirror images. So that would be a yes. And then how about number 6? It does look, it's a rhombus, right? It's kind of like that slanted square. And the slants can kind of be misleading sometimes. This would actually not be a line of symmetry here. Because again, the angle measures, them not being right angles, creates that slant. And if I were to fold this over and then this over, they would not match exactly. So they would be a little bit off. There would be a little extra hanging over. Number 7, obviously a no. And number 8, yep, that would be a line of symmetry. So I like our math talk right here. How can you use paper folding to check, right? First you would have your shape, and then finally you're gonna fold the shape in half different ways, and that crease that happens when you fold the paper gives you a good visual of, you know, are they mirror images of each other. Let's go ahead and we're gonna shift up to the on your own, and I would like you to pause the video and see what you come up with for 9 through 12. So go ahead, pause, take a look at them, give me yes or no, and then we'll come back here in a minute, okay? Pause. Okay, guys, so 9 through 12, you should have answered. Number 9, that would be a, I'm goofing that up, aren't I? So number 9 should be a no. Right? At this little curve right here, they would not match up. It would need to be kind of like a dip right there. 10, that would be a yes. Number 11, that would be a no. This is a skinnier arrow, and this is kind of like a chubbier arrow. And then number 12 would be a yes. I like the hot problem down below. Complete the design by, now in this case, you're not looking to see if it's a reflection. You're trying to create the reflection on your own. So, for instance, for number 13, 1, 2, 3. So I'm going to go over 1, 2, 3 along the top. And then I'm going to come over 1 down below. And then I'm going to connect those lines at a diagonal as best you can. So I'm going to try to connect that line and create that mirror image. Same thing with number 14. I'm going to go down 1 and go down 1. I'm also going to go, let's see, this is 1, 2, 3 to get to the top. So I'm going to go 1, 2, 3 to make the bottom. And you kind of just have to keep looking back at the image up top. No, I went too far here. Get your eraser out. Look, Miss Howell's already having to erase. And so these would connect, and then these would connect here. Oops. Did I do that right? Yeah, I think I did. I just have a bad time connecting this. Okay. And then let's see. So we have our triangle here. So I'm going to count 1, 2, 3, 4, 5, 6. So I need to go 1, 2, 3, 4, 5, 6. And then that tells me like where to put that line right here. Okay, I redeemed myself with number 15. Oh gosh, there's a curve in number 16. So, okay, so if this is 1, 2, 3 on this side, on the bottom, I need to go 1, 2, 3 on the top. And then I'm going to go here. And then, see, this is where it starts to curve right here. So I know at this point I need to like start to do a curve. That wasn't too bad. All right, disregard 14. The other 3 don't look terrible. Okay, let's move on to our final page, page 402. Okay, for page 402, I'd actually just like for you to try to solve and answer 17, 18, 19. So I want you to take a minute and just, really look at our shapes, do your multiple choice. You don't have to worry about our answer, like filling this in right here. I just want you, can you answer and bubble in the correct shape that represents a line of symmetry? So pause the video, try 17, 18, 19, and then come back and I'll model them for you. Okay, for number 17, again, you should already have this filled in. You have which shape has a correctly drawn line of symmetry. That would be letter C. This horizontal line going left to right creates a mirror image top and bottom of that shape here. And then let's look at number 18. It says which shape appears to have a line of symmetry. And I would say, let me eyeball that. Just at a glance, I can see if I do a horizontal line right here, that kind of jumps out at me, or a diagonal line, that kind of jumps out to me for letter C here. If I do a horizontal line there or horizontal, that shape doesn't work. And this shape is the same thing as that guy, just turned sideways. And then this one right here, it looks like D, but it's slanted. So letter D looks like C, but it's slanted. So I think C is our best bet for a diagonal line of symmetry. And number 19, which best describes the line of symmetry in letter M? Would it be a horizontal, a vertical, diagonal, or rotational, which we didn't talk about? So hopefully you didn't pick rotational. Letter M would be I'm getting worse and worse on my lines. So letter M would be up and down is vertical. Okay, we should know vertical, horizontal by now. All right, guys. So tomorrow you should have your corresponding workbook pages. I look forward to seeing what you guys come up with, and hopefully if you have any questions on symmetry or you're still feeling a little funky, make sure you jump on my Zoom lesson at 2 o'clock. Fridays at 2. I generally always go on Zoom to answer your questions. Hope to see you there. Bye, guys.